All right, everyone. Thank you so very much for making it down to this study and slash, I don't know why we call it teaching or studying, whatever we want to call it. And then if you have been following from last week where we had introduction to the course, and then we introduced ourselves. The second thing we are doing this week is linguistics and natural language processing. I am Olanrewaju Samuel, a computational linguist at Mbaza NLP, and I teach natural language processing at Center for Integrated and Development Research Action at the University of Rwanda, here in Kigali at the moment. Right, so just stop me where you want to ask questions. If you have questions, just stop me by. I would be happy to answer your questions. All right. So, sorry. So, what is the aim of this particular unit? At the end of this course, I aim that participants will demonstrate their knowledge of linguistics as relates to natural language processing, provide interrelation between linguistics and natural language processing, provide a summary of the interdependency of linguistics and natural language processing. So basically, this unit is all about linguistics as a body of discipline, natural language processing as a body of discipline, which we know that, of course, linguistics is a part of what made it up. What do they share in common? What do a theoretical linguist, let's say statistician, have to do with natural language processing? What does a phonologist have to do with natural language processing? What will a sociolinguist do with natural language processing? I hope you enjoy this ride. Let's move it. Okay, so I won't dwell much on this. What is linguistics? It is the scientific study of language. It deploys relevant scientific procedure to unravel what people know about their language. So pay attention to the fact that linguistic studies, the scientific study of languages. It doesn't just study human language as in a form of learning the language, as in being a polyglot, but understanding or providing procedure to unravel what people know about their language. Now, I put some claims here. Linguistics does not learn languages in terms of learning language, as in learning French, German, or have, but linguists have structural knowledge of languages. So, for example, if you are working on Kakchika language, you are a native speaker of Hausa or Yoruba or Igbo, or even Isizulu or Isizulu, then you are speaking Kakchika as a structural language. So you don't necessarily have to learn the language. You are just having the structural knowledge of the language, the grammatical, the structural patterning, whatever structure, whatever part you are focusing on. Linguistics do not study the grammar of a language, but properties of human languages. So linguists are not really, when I say grammar here, I mean that linguists are not studying French as a language in itself, but understanding the properties of human languages, as in what do Yoruba, French, Hausa, Igbo share in common, for example, or what do French, Igbo, English share in common? I mean, I'm just trying to give us a snippet of what linguists do. All right, so levels of linguistics. So phonetics and phonology. I put phonetics here and phonology together here. They are different levels, but I put them here for the sake of NLP. All right, so phonetics studies human speech sounds. Phonology studies the patterning and system of the sound in a given language. So phonetics studies what I would say plausibility of human language, of human speech sound. That is, in the primary organs of human, what are the plausibility of where human can produce sounds? Now, phonology studies what and where languages use these phonetic sounds. So in a way, you can have phonetics of English, but you can possibly not have phonology. You cannot have phonetics. Sorry, you can have phonology of English, but you cannot have phonetics of English. Why? Because phonetics, we study human speech sounds, except you are doing phonetic analysis. but you can have phonology of a language. That is, you are studying the pattern or the system of a language, of sounds in a language. But you can do phonetics of human languages, right? I'm emphasizing that for the sake of NLP, right? Morphology is another level. This studies the internal structure of languages in what order? Uh, Typology, uh, morphological typology, the analytic and the synthetic languages, whatever way you want to look at it. This is what morphologists do. Syntax. This studies the structure of sentence constructions in a language. So sentence patterning, grammar, rules governing the structuring of words together to make longer sentences from phrase to clause. Whatever you want to look at is linearity, how we string constructions together. Semantics. This study the meaning of and sense relation of lexical items in a language. So look at it. Linguists pick language as in levels in terms of studies, right? So now, what is natural language processing? Natural language NLP, natural language processing is the process of helping machine understand, generate, write, and interpret languages. Now, pay attention to the fact that we are saying understand, generate, write, and interpret. So linguists are studying what people know about their language, right? So what NLP is aiming to do is how to help machine to do what linguists are doing. Basically, how to provide a way of making machine, when I mean machine, our computer, whatever thing we want to think about, our computer to understand, to generate, to write, and interpret languages. Don't forget, machines don't read words. Machine reads number. So how does NLP help, or how has it been able to convert the words that we speak into numbers that machines speak? That is the bridge. Now, the branches of NLP, we have natural language generation. This is how to use computer to produce languages. And these are the two broad types. The second one is natural language understanding. This is how computer understands language, so data, sentences. That is as simple as that. So NLP, linguist studies underlying things of what people know about their language. NLP is using machine to do what linguists are doing. Right. So I want us to look at the data that we use in NLP. Forms of NLP versus linguistic data. In NLP, we have just basically two types of data, really. If not lately, when we have signed language, basically NLP deal with data in terms of the spoken, the textual, and perhaps lately the sign language. So when we say spoken and textual, we have just speech and text. So speaking and writing. Now, in terms of linguistics, what do we have? We have spoken, written, linguistic property, analysis. So here, I'm trying to tell you that linguists, even though they can be doing spoken data, they do linguistic analysis. They want to know the properties of that data. NLP practitioners don't really care. What they do is, if they are working on a spoken data set, let's say they are doing an automatic speech recognition system, they just get the audio data and put it in machine. Don't forget, they are helping machine to understand language. If it is text they are working on, depending on the type of learning system they want to give the machine, they just pick the text without analysis, without properties, linguistic properties. They just want to put it in the machine to train their models. So now, linguists in NLP. So what do they share in common? Where do linguists really come in real time? Where do we find linguists? So phonetics and NLP. So here, phonetics provide help phonetics is important for NLP in terms of orthography. Remember that phonetics studies human speech sounds. And then, since phonetics studies human speech sounds, graphing and sounds are what we do in orthography. How do you represent the sounds of a language? That is one primary thing phonetics is doing in NLP. So basically, broadly, we have two types of orthography, the transparent and the opaque. In the transparent orthographical system, there is one-to-one correspondence between sounds and graphemes. So the way you speak is the way you write. In a language like Yoruba, where oko, farm, o is o, ka is ka, o is o, nothing more. So in an opaque system, there's no one-to-one correspondence between sounds and graphemes. Look at this badge. We have bad in English. Now you see that I put that DZ here just for analysis sake and just to understand what we are doing. All right, so in an opaque system, there is no one-to-one correspondence. So it is not the way you write that you speak, or it's not the way you speak that you write. Now, how do machine convert phoneticians or phonetic work into NLP work? Right. There is something designed called alphabet. Alphabet is basically mostly applied to Latin scripts, and it is used to write English language, American English, and British English most of the time. It is used to convert the sounds to the orthography that NLP or a machine can read. It is a way of preparing the writing system of a language so that machine can read. Alphabet. Right. So text encoding. This is what phonetics is doing. What is text encoding? Text encoding is how do you encode the text for machine to read? I mentioned alphabet, right? So alphabet is designed to read English, most of the time Latin alphabet, really, Latin scripts. Now there is American Standard Code for Information Interchange, ASIC. Now this ASIC was designed first to read English and to read American dialects or to read British English. But because of languages where there are IPA symbols serving as orthography, because they don't have orthographical maybe correspondence in Latin scripts or Roman script, whatever script they chose to use. So because of that, some languages actually have IPA symbols serving as their orthography or letter or in the orthographical system. Now, because of that, there is a limitation because in creating ASIC work more with alphabet. Alphabet was designed solely for English language. So in English language, we don't have an instance where IPA symbol is serving as the grapheme. No. Rather, we have a lot of complications in the vowel system where two vowels can communicate to become one sound. One sound can be two vowels. There is no one-to-one correspondence. So these forced scholars to design Unicode. Now, Unicode is another type of text encoding, and it is more encompassing. It has about over 140,000 characters, and it contains both the IPA symbol and the grapheme symbols. So it makes it easier for machine to read, particularly UTF-8, that's Unicode 8. So UTF-8 is what most, even in Python programming, in whatever programming you're doing in linguistic work, if you are using LaTeX to write your paper, you basically work with Unicode because that is what makes machine easier to interface with human language. Now, there is a process of converting text to integers. I think I raised this question earlier. This process is called quantization. Quantization is a process of converting text into numbers. Remember the machine reads in zeros and one. Machine do not read 1, 2, 3, 4, 5, 6, 7, 8 to infinity in that sense. It reads 0, 1. So most of the time, to work with machine, which is what linguists have been saying, doing over time, is to do statistical analysis, probability. So, if you have probability, it's either 0 or minus. Is either 0 or 1. So is it there or not there? So quantization is a way of encoding machine to convert the text to integers. You can see that what linguists are doing basically here is to prepare and work on the data, morphology and NLP. So what do we do? Morphology that interface with NLP is creating machine algorithms to understand human languages, using different systems such as automata to create machine algorithms, preparing different ways to understand morphology typologies, analytic, relating, synthetic, agglutinating, and fusional languages. What we do here is to prepare the data for machines to be able to read. Now, remember that machines don't actually read letters. What they read is numbers. So now, if you are talking about creating algorithm system, it doesn't necessarily mean all the time you have to program. It also means that you prepare an input for machine to read. So how do you prepare morphologically an input, or should we say language input, for machine to read? Syntax and NLP. So of course, just as we have seen, syntax in NLP saying, how do we create an algorithmic system for machine to learn parsing, to learn part of speech, segmentation, dependent and independent sentences? How do we parse the sentence? And then why do we have to actually teach machine? Because machines see numbers, machines see data. We see sentences, right? So data set is just a list of sentences, can be words, can be phrases, can be whatever we want to think about. Is just language words, like as simple as that. So in syntax, we prepare a machine to know both universal and parametric structure of human language. Gram Bank is a new research. I think it's relatively news was released, I think earlier this year, on how it's from Institute of Max Planck Institute, and they are aiming at creating something like a universal grammar for NLP, more like that. So in syntax, interfacing with NLP, we are providing grammar summaries for machine to learn. Don't forget, here again, we are working on the input for machines. We are not programming. We are preparing data for machines to use syntactically. Semantics and NLP. We are providing disambiguation strategies for machines to use. The word bank can mean different things, right? So bank can be bank of river, can be bank to keep money, can be bank, it can be just bank. So bank, it's semantically ambiguous. So how do we provide data to disambiguate such instance? In some languages, morphologically, there are ambiguities. So the morphological system of the language is not about fusional now or fusional languages. It's about the fact that a morpheme has different meaning depending on the context you are finding it. Tonal patterns too contribute to this kind of difficulties we found in languages. So the question is, what are linguists or should be or are doing in this case concerning semantics and NLP? Making different algorithms for machines to learn meaning in form of interdependencies among different lexical items in a given language. So machine does not have retentive memory in terms of learning bank. The bank I learn now is not the bank I will learn later. Rather, machine learns interdependent, try to check, okay, the bank in this context is not the same thing with the bank in another context. So it relatively learn the patterning of a language using, depending on the model you're using, if you're using rule-based or statistical-based, using the data set that is given to it. Sociolinguistics and NLP. What do sociolinguists do, or what will sociolinguists do in NLP? Sociolinguists studies the interrelation between language and society. I would say sociolinguistic studies the variation that occur or that is in a language over uh, demographic or demographics or should I say societal or geographical locations. So uh, sociolinguists provide us insight to learn different versions of languages. Uh, they provide us learning language variation across geographical locations. Provide linguistic variables that differentiate language variation. So we want to know why the Yoruba spoken in Nigeria is different from the one spoken in Benin, for example. Sociolinguists can provide us with linguistic variables that make such distinction. They provide insights to accentuation. So what I mean accentuation is uh, how would you can call them socialites, how, or you can say it in terms of saying how would a man, for example, pronounce the word boy that makes it different from a woman pronouncing the word boy, or how would uh, somebody from East Africa pronounce the word boy that makes it different from somebody from West Africa pronouncing the word boy. Accentuation. That is what I mean by that. All right. So what would sociolinguists be doing? They are providing us with insight on the machine or on the language. They are providing us insight on the language, which is the input of any NLP system. Right. So machine learning and linguistics. Machine learning, in simple terms, making computer learn without or with little instruction. So if you machines learning, more like machines are learning. How do machine learn? So machine learn by making computer learn without or with little or no instruction. So you are not helping, you are not giving instruction to the machine, you are just giving the machine input, which makes it very important not just to give input to machine, but to give the input to the machine in a systematic way. So you don't just give machine data, you must give the data the expected, you must give the machine the expected data. Because if you give machine anyhow data, machine will do anyhow. Why? Machine does not have an intelligent system in that to differentiate your action from your words. For example, you give it the word, it works on words. You give it action, it works on your action. But broadly, there are three types of learning that machines do. We have the supervised learning. In supervised learning, what we do is that you label the data and you give it to a machine to learn the patterns. So when you're labeling the data, I mean, data, for example, if you see if you are putting part of speech in a word, for example, and you want machine to learn, we will still see that in other modules or other units of this study group. And then the boy is here, and then you label the boy as noun or noun phrase, and then he's here as his predicate, right? So if you teach computer like that, when you say the boy now, like that structural pattern, and then you have like 1 million sentences that you have labeled, if you give it to machine can learn the patterning, and then with that follow what you have done, and then when you give it another type of data, which is the test data, it can replicate what you have taught it in it. In unsupervised learning, you give machine just the data, it figures out uh, the patterning itself. Recent studies such as Bagos work, they are even making it a bit advanced. They give machine just audio data and it's gonna figure out the syntax, the phonology, and whatever patterning you want to ask the machine. It is so crazy and mind-blowing. Now, in semi-supervised learning, you are combining both the labeling and then, okay, you label, let's say you have 100, let's say you want to train machine with 100 sentences. You can label 50 and give it another 50 on label so that it can learn the pattern and still apply it in the same body of data. That is semi supervised learning. Now, what will linguists be doing here? You may ask. All right, I want to take us back to language acquisition theories. That the unconscious way of acquiring languages. By acquisition means you are not conscious. Now, there is a theory called connectionism and constructionist and then reinforcement learning, like reinforcement theory. Now, in connectionism, we learn by forming connection between stimulus and reaction or response. And that is what machine is doing. Machine is forming a connection between your label of data and what you are trying to teach it. For example, if you are on a semi-supervised learning, you are giving machine two type of things to do, right? You are teaching machine that, okay, look at this, look at this, look at that. ABC is ABC is ABC. When you have a blank check, machine can say, okay, this is ABC, this is ABC. So it's responding to the stimulus. So linguists are contributing or should be contributing to the way machines are learning. Constructionism or constructionist. They said active learning is by forming one's mind. So look at the case of unsupervised learning. Machines need to figure out the patterns of data in itself. This is what linguists have been doing over time. Linguists believe, or so, a theory of linguists, or a sect of linguists believe that language can be done or can be learned by forming one's mind. Learning, actually, acquiring, active learning of a language can be done by babies figuring out the data themselves, right? Reinforcement learning says if you are learning a language or when you are learning a language, you are liable to use a form that you are praised for than a form that you are rebooked for. For example, it is not enough to learn a language, you must know when to use the language. For example, in Africa, especially in Nigeria, where I grew up, we don't just talk to people anyhow. Like our elder, so people that are older than us, we tend to give them the pronoun system. When I mean pronoun, I mean plural pronoun system. So, which is why a child learning, or a Yoruba child, for example, learning English, would tell a fellow student or his mate, if it, when his dad is his or dad is coming, he says, uh, uh, they are coming because he feels that the dad is, it's not like he's taking the dad as being plural as in English, the dad as being somebody that is respected in court, right? So if you stop at the child and say, don't learn, don't say this again, say it like this. But then the child says, but you said I should say it like this. No, don't say it like this. Rather, say it like that, right? So in that way, you are teaching the child. When the child is learning, uh, yeah, when a child is learning, a child is not just learning what you taught him or her, but is receiving a form of reward and a form of scolding for using the wrong form or for using the right form, right? So yeah, it's honorific pronoun, but I want to desist from using the term honorific pronoun in this context, for the sake of this teaching. Now, you may ask yourself, so how do I get started? Now, remember, I've been saying that whatever thing we are doing in linguistics, we are working with data, we are not working with machine, right? What we are doing is we are working on data. So linguists should actually strive more to know when and how, for example, phonology is applicable at a point in the input you give to machine. Why? There is no NLP without data. What do you want to feed your machine? Machines don't by themselves generate something. They take input and they give you output, right? So, which makes it very important for linguists to know about data sets, data creation, how to collect data, how to annotate data, how to provide data statements, how to provide schema for data, and whatever thing you can think about on data. So at this point, I'm going to make two distinctions. For me personally, difference between natural language processing and computational linguistics. Now, in natural language processing, we study how computer learns language, right? In computational linguistics, we study how language is applied in computer. It's an applied linguistic field, right? So you see there are two directionalities. One is moving from computer to machine, now from machine to language. And the other one is moving from language to machine. So which means that the one that is moving from language to machine is more interested in the language than the machine. The one that is interested, that is moving from machine to language, is more interested in what machine is doing with the language. So two different where they are very related, but then they are two different fields. But from my personal research, it appears that sometimes what they name departments, especially in where they have computational linguistics and NLP together, is that depending on the number of faculty that is there. For example, most of the time when you see if you see a department where there are faculties that are more of computer science, namely natural language processing, if there is a department that they kind of have more linguistic, namely computational linguistic department. So maybe it's my personal research or observation. This is just my own observation. It's not anywhere. All right. So data and data. Algorithmic creation can only work on given data. Machines do not self-create knowledge. They rely on human input. So machines will not all by themselves begin to create data. Machines would only create data based on what you tell machine to do. So machine or algorithms or NLP as a whole cannot stand on its own without working on data. You can barely see any NLP work without data. So this is where linguists come in. Linguists can contribute by building data sets. They build data sets from different ways by understanding different NLP tasks, by understanding what is what and which is what we'll be doing in this course. How do I collect data for NLP tasks? How do I annotate data for NLP tasks? And back and forth. So this is where we'll be pausing concerning linguistics and natural language processing. If you have questions, do let me know now. Do you have concerns? Do you have questions? Can we raise our questions now? I'm trying to take the chat, but can we ask our question? Do we have questions?
Hello.
Yes.
Yeah, yes. Can you hear me?
Yes, I can hear you.
Okay, thank you very much, Prof, for this
Sorry,
concise and wonderful.
I'm not a prof. I'm Samuel.
Okay, thank you. Anyway, well, coming from Africa, we use some kind of honorific title for teachers. So thank you, sir, for um this wonderful and concise introduction to language and NLP. Two major things were brought out here probably at the end of the lecture, where you spoke about NLP, trying to distinguish it from computational linguistics. Then I wish to know where exactly digital humanities comes in here. The connection between these two concepts and then digital humanities is not mentioned here anyway, but then I'm just thinking of how do we connect the three of them together? I don't know whether did you get my question?
Yes, I do get your question.
Okay.
Yeah, thank you so very much for that question. Yes, digital humanities. Well, I am not a specialist in digital humanity, but I think how to digitize human research actions is what digital humanities is all about. So you will pardon me if I'm going over the board.
Okay.
So basically, if we are trying to do computational linguistics in terms of working on data, digitizing the data, we are doing digital humanities. So for me, I believe that computational linguistics work encompasses also digital humanities, or should I say, digital humanities will house everything that is with computational linguistics and corpus linguistics. So digital humanities is a bit broad. It's not just about linguistics alone. Digital humanities will be in history too. Of course, you can deploy different linguistic tools, such as AntConc. You can use AntConc for historical data. You can use AntConc for whatever data you are working on, just to, of course, work on the data. If you are dealing with data curation, for example, which is something you do in computational linguistics too, you are doing digital humanities. So basically, they are interrelated, but I think digital humanities is broader than computational linguistics.
Okay, thank you. Thank you very much. Then which other programming language is preferred for computational linguistics or even NLP? Which will you, as we are beginners, which one will you advise us to maybe start trying to acquaint ourselves with?
Okay, thank you so much. Last week, I think I made it clear. I am not sure I would take programming in this course. This course is not for technical aspect of NLP. It is a way to just make it simpler and use what programming would do or what Python would do by with linguistic software. So we are going to be using linguistic softwares to mirror what you would do with programming. But when you are talking of what programming language you should use for NLP or computational linguistics, of course, Python tops the board. For me, I prefer R statistics. I use R programming because it's simpler for me and it's easier to use. And then I love the visualization because I work more on data. Right. So, but Python R, yeah, that's. But you can use Java. You can do other languages depending. But Python is, at least as far as I know, is widely used. Dan Lamin, are you the one raising your hand? I think Dan Lamin is raising his hand.
Yes, please. Good evening, everyone. Thank you. You said we shouldn't call you Prof. Well, actually, thank you, sir, for the wonderful presentation, which is very educative. Mine is a question about tonal languages, especially Hausa. Tone are marked in most Yoruba writings that I come across with, but Hausa words are not tone marked. So how do we get the machine to learn probably between words that are spelled identically, that is phonologically, but phonetically we don't differentiate them using the tone? How do we teach the machine to differentiate this, or rather to address this anomaly? I hope the question is clear.
Very clear, sir. This is one of the reasons. In fact, I could say this is my primary reason for hosting this study group. So now, thank you for that wonderful question. Tonal grammar and tonal languages are lagging behind in terms of NLP. Why? Because we have less NLP practitioners with linguistic background or less linguists in NLP, or the system of tonal grammar, it's a bit complex than what you can really think of. And then because NLP practitioners just dwell more on their spoken data, they don't care whether it is tonal really. Machine is learning it. I mean, it's just learning it. And then the danger of that is we can't trace what machine is learning. We can't know when machine is wrong because you're just giving machine data and it could be anyhow data. And machine will do anyhow if it's learning anyhow, right? So one of the reasons of hosting the program is to teach linguists to be equipped using linguistic softwares to work on a system such as tonal grammar. Yoruba is a bit simpler because we to mark. Hausa don't to mark. You know, Hausa can say churn and churn. You can say none and none. Like here, depending on the distance you're looking at, where tone can make different meaning of a word, right? So yes, we will come to this. For me, the approach I have deployed or the approach I have been thinking about is working on the tonal languages as a morphologically rich language. You know, I know Hausa is rich morphologically, but not as rich as Bantu languages. But I feel that if we can attract or if we attack tonal problems using morphology, we can solve the problem. For example, if we are thinking about tomorphs, we can take tone as if we can take lexical tone as a form of tone, and then take tomorph as a form of another type of tone. Then there's a way we can annotate it. When we get to data annotation, I would show us my approach. So we can use different systems to target so that machine can learn that at this point this is low tone and it is different from this point, which is high tone. So that is my own approach for now, but it is really lagging me, and that is an interesting observation.
Thank you very much. Thank you.
Yes. Thank you, sir. Do we have other questions? We can type our questions. I'm trying to check. Okay, somebody
Hello,
wants to talk?
Hello.
Yes.
Please, I don't know if some of us, if what we are concerned with, our concession here is the lecture, or can we ask maybe questions about probably admission and maybe some other process and protocols or difficulties we are encountering with regard to being admitted into the institution? Can we discuss that here? Or what we are for here is mainly the lecture?
Okay, if you would be talking about scholarship and gaining admission, I would suggest we make it a different module, and then it depends
No,
on
no,
what
no,
people
no, it's
want. It depends on what people want. It will be a long talk because I think I have some ideas and I have some proven track records concerning such things. So I don't want to mix it with a pure linguistic talk. We can give that a different class on its own, and I will be ready to share a lot of insights.
okay. Then I will contact you from the what is the link you gave there, even though it's just about you, University of Ibadan. That's why I wanted to find out, but maybe we talk privately then.
Okay, then. All right, that's fine.
Thank you.
Do we have questions? Do we still have questions? Do we have questions? While I think somebody is dropping questions on the chart. Are there certain languages that are easier for NLP models to program, like English versus German versus Yoruba, for example? ChatGPT uses a trillion parametric, sorry, I can't see this very well. Parameter, is it parameter? As far as I know, okay, ChatGPT uses trillion parameters. As far as I know, is that unique to English language? Would other languages use more or less? Okay, yeah, the size, if I don't really get the question, but in NLP, there are low resource and high resource languages. And high resource languages is just the term high resource language just means that languages with more NLP work on them. Low resource language is just language with less NLP work on them, less the data, less work. So of course, in the case of ChatGPT work, of course, we work on more data, and in regard to that, it works more on English. Because it works more on English, it works more on, because it works more on data, it works more on English. So English has higher, more data, like for example, Yoruba language. So of course, you don't expect that. It doesn't mean that the NLP algorithm will work better with English. It only means that it works better on a language which it has more data. So everything works by data. Do we have other questions? Do we have other questions?
Please, I am Munyolu Watalabi. I want to thank so much for this opportunity and for the teaching of today. I want to ask, what is the future of education with this advent of ChatGPT, please? The thing is a bit worried, though it's useful. I use it. I'm using it as well, but I'm seeing a downturn in education with this advent of of ChatGPT and other writing tools. Though it makes the work to be easy, one kind, but at the same time, it will make us to think less. I don't know. I'm just looking at the dangerous side, the other side of it, to the future education, to education in future.
Okay. Well, I don't know what you mean by the danger of ChatGPT to education. The question is, what is education? Why are we educated? Are we educated for literacy's sake? The fact that you can write English well does not mean that you are. Does good writing system of English or does writing skills of English make you intelligent or educated? I think I've got this many questions many times. The question is,
less.
if you say think less, if you think less, what do you mean? Like you mean that the questions students are given would be easier for machine. They will use machine to solve that. They will not think.
Even myself as a lecturer, I use machine this day to even do some things as well. Though I still do editing, but it's like I'm not as alert as before. I'm just being honest here.
Yeah.
And I think
the point is, for me, I see a complex system. The world is becoming more complex, and then lecturers need to get more complex too. So you don't just give students what is linguistics or what is phonology like that. Is not engaging. Like, well, I don't really know. There are dangers of ChatGPT and all those things, right? But I'm not really interested in that for now, especially not at the moment. But if you say danger to education, I begin to ask myself, are we educated to write English? Are we really educated to write only English? That's the question. If I can't write well, does that mean I'm not educated or I'm not? To be literate is not to be educated. That's what I'm saying. It's beyond literacy. Of course, literacy is part of what you learn in education.
Okay. Thank you.
Yeah, yes. So do we have questions? So we have about 3 minutes to round off. Do we have anyone with question? One more question and we'll call it a day. All right. For those that didn't know, there is a link. I don't know whether on the WhatsApp group, there's a link to resources on this course. This slide will be there. Every material will be on that Google folder. You can just open the folder and download the textbook you have that you want. I have the slide there. I have the textbook there. I'll be uploading more materials, and then the link to this meeting will also be in the link. So just make sure you go over the link and then join the chat. So thank you so very much for making it down today. We're gonna be calling it a day. The link is on I'm not sure, it's on the WhatsApp page, and I'm not really sure I want to locate it at the moment. So thank you so much for coming around. I am really grateful. We will meet next week, same time, same venue. See you next week.
Please